Okay, in this video, we're going to look at finding the slope between two coordinates that lie on the graph. And so we don't actually have the graph to look at to do rise of a rho. We're given 2 points. Then we're going to build upon that to going back to writing the equation of a line when all we know are the 2 points that it passes through. The formula in order to find the slope between two coordinates is you take and you find the change in y, which would be y2 minus y1, divided by the change in x, which would be x2 minus x1. Now, it doesn't matter what coordinate you label as x1, y1, or x2, y2. The only important thing is remember that I have an x and a y in the same coordinate, and it's not x and y in the same coordinate. So, let's find the slope of a line that passes through the points 6 by 14 and negative 6 by negative 2. So I'm going to label these for right now as x1, y1, x2, y2. Now the slope of the line that passes through those points is going to be y2 minus y1 over x2 minus x1. So all I have to do is plug in. y2 is negative 2. So I'll put negative 2 where y2 is, minus y1, which is 14, over x2, which is negative 16, minus x1, which is 6. And then we just simplify that. Negative 2 minus 14 is negative 16, over negative 16 minus 6 is negative 22. And then we reduce. Two negatives make a positive. 16 divided by 22, both numbers are even, so I divide them by 2. That makes 8 over 11. Let's look at another example. Same mission here. Find the slope of the line that passes through the 2 points. Label them as x1, y1, x2, y2. Our slope formula for the slope of a line between 2 points is y2 minus y1 over x2 minus x1. And then we put their values in. So y2 is 14 minus y1, which is 17, over x2, which is 10, minus x1, which is negative 15. And we simplify. So we get negative 3 on the top. Back-to-back minuses makes a plus down here on the bottom. And so negative 3 over 25. Okay, now let's proceed and make this a little bit more difficult. So let's find the missing value, x or y, so that way we have the given slope of a line that passes through these 2 points. So this time we know what the slope equals. The slope in this problem is negative 3 over 5, and we are given a coordinate x comma 3 and negative 2 comma 0, so we need to solve for x. So let's call that, we'll label our points x1, y1, x2, y2. And we're going to use our slope formula, which says m is equal to y2 minus y1 over x2 minus x1. And let's put our information in. Well, the slope is m. So we'd have negative 3 over 5 is equal to y2 minus y1 over x2 minus x1. And then we try to work to solve from here. So our problem would become negative 3 over 5 is equal to negative 3 over negative 2 minus x. So we look at this problem here, and this is the first time we've seen a problem like this all year. And what we have is we want to solve for x, and we have 2 fractions. Well, notice the fraction on the left has a top of negative 3. And the fraction on the right also has a top of negative 3. And since we have this equal sign, if we want to make those 2 fractions equal, since both their tops are negative 3, that means both the bottoms have to be equal to 5. And so we're going to say 5 equals negative 2 minus x, and we're going to solve that equation right there. So I'm going to move the 2. I'm going to add it over. we have 7 equals negative x. And all we have left to do is divide by a negative. And we get negative 7 is equal to x. So that missing x value we needed to make that slope was negative 7. Okay, let's do the same thing again, but this time we're solving for y. So we know the slope we want to have is 1 over 3. We're given the coordinate negative 2 comma y, so I'm going to label that as x1 and y1. And 4 by 9, so x2 and y2. And we're going to set up the equation using our slope formula, m equals y2 minus y1 over x2 minus x1. We're going to plug in the information that we have. So we have 1 over 3 is equal to 9 minus y over 4 minus negative 2. So I put y2 and y1 in and x2 minus x1 in. We have 1/3 equals 9 minus y over 6. Now, we don't have as easy of a problem as we did before here because the bottoms are not the same. See how this bottom on the right-hand side is 6 and the bottom on the right-hand side is 3. So I would need to do a little bit of work here first. If I would make the bottom on the left be the same number, then I could set the tops equal. So I'm going to take and I'm going to make that 3 a 6 by multiplying it by 2. And if I multiply the bottom by 2, I have to multiply the top by 2. So my problem becomes 2 over 6 equals 9 minus y over 6. Now that the bottoms are the same, I can set the tops equal to each other to solve. So we're going to say 2 equals 9 minus y. And then we would solve from there. So minus the 9 over. Negative 7 is equal to negative 1 times y. Divide by my negative 1 here. And we get 7 is equal to y. So the y value I need for that coordinate has to be 7. Now, let's write the slope-intercept form of a line that passes through those points that were given. So in order to write the slope-intercept form of a line, if I have two coordinates, the slope-intercept form of the line requires me to know the slope and the y-intercept. Well, when I'm looking at this problem, to find the slope, I have to know, I label my points as x1, y1, x2, y2, and determine the rise over run. So our slope, m, is equal to y2 minus y1 over x2 minus x1. And I'm going to plug in all of my information. So m is equal to y2, which is negative 1, minus y1, which is 5, over x2, which is negative 3, minus x1, which is 0. And I simplify that. Negative 1 minus 5 is negative 6 over negative 3. And we get a slope that is equal to 2. So I know m is 2. Now I just got to find b. So my equation right now is y equals 2 times x. Now, we know we are given b. B is the y-intercept. Look at the coordinate 0, 5. 0, 5 is on the y-axis where 5 here is b. So b equals 5. I didn't need to use that other formula of ours. So our equation is y equals 2x plus 5. Now the next one. Write the equation of the line that passes through the points negative 4 by 4 and 2 by negative 5. So our goal is to get it in this form. Y equals mx plus b. Now we're looking and we have to find our slope. So the slope would be y2 minus y1 over x2 minus x1. So I'm going to label my coordinates x1, y1, x2, y2. Put the numbers in where they go. So y2 is negative 5, y1 is 4, x2 is 2, x1 is negative 4. And so we start simplifying. My numerator is negative 9. My denominator, negative 2 minus negative 4 is 6. That reduces down to negative 3 over 2. So I have my slope. negative 3 over 2. Now, I need to get the slope-intercept form of the line, but the problem is I don't know what b is. We were not given the y-intercept. So we're going to have to use our other formula to write this equation of the line, which is y equals f of c plus m times x minus c. So we have to pick a coordinate. The coordinate I'm going to pick here is the first one, where the negative 4 is the c, and the f of c, which represents the function's value, the y value there, is going to be the y value, the point of positive 4. So I have y equals 4, and then m is negative 3/2, so it'll be minus 3 over 2, times x minus negative 4, which turns that into x plus 4. And that's the equation of the line. All we have left to do to write in slope-intercept form is distribute the 3/2 and combine like terms. So y equals 4 minus 3/2 x. Negative 3/2 times 4 makes negative 12 over 2, which is negative 6. And we put the numbers together. We have negative 3/2 x. 4 minus 6 is negative 2. Last thing in this video is to write the equation of the linear function represented in the table. And so we keep trying to write the equation of lines, but I keep presenting the data to you differently. A table is nothing more than coordinates that are divided up, where their x values in one row or column and the y's are in the other row or column. And so in order to write our equation, slope-intercept form, we need to figure out what m is. So m is the slope. Well, what you would do is you're going to pick out 2 points out of this table. So I'm going to pick negative 4, 8, and I'm going to pick the one next to it. Negative 3, 10. I'm going to go find my slope. So my slope is going to be y2 minus y1 over x2 minus x1. And so I'm going to put in the y's and their x's. So I'm going to let y2 be the point on the right and x2 be the x value of the right, and then y1's and x1's be the one on the left. So my slope would be 10 minus 8 over negative 3 minus negative 4, and which is going to give me 2 over 1. So my slope is 2. So at least we don't have to deal with a fraction. Now we're looking, and we don't know what the y-intercept, because the y-intercept has to have an x value of 0, 0 comma some number. Well, we don't have that information. Now, in this table, if I'm looking here, and I know that the slope is 2, what I can do is I can continue this table on and go find the next point, because the next point, looking at the table, we go negative 4, negative 3, negative 2, negative 1, continue the pattern. The next number would be 0. And so all I would need to do is copy the pattern for the y's, and I'd have my y-intercept for b. 8, 10, 12, 14, we're adding 2 each time. I got 16. So 16 is equal to b. So the equation of this line would be y equals 2x plus 16. Okay, last one here. So I'm given a table of a line, and I want to write this slope-intercept form of the line. So y equals mx plus b. I need to find my slope. So m is going to equal y2 minus y1 over x2 minus x1. And I'm going to use the first 2 points again. They tell me it's a line, so it doesn't matter what points I use. So I'm going to let the one on the right be my second coordinate. So x2 and y2. So it'll be y2, negative 8, minus y1 and negative 3 over x2 of 6 minus x1 of 3. So the slope of this line is going to be back-to-back minuses makes a plus. So I'd have negative 5 over 6 minus 3 is 3. So I have negative 5/3 is m. Now all I need is b, which is my y-intercept. Now remember, the y-intercept is the value of y when x is 0. Well, let's look at the pattern in our table. We're trying to avoid using that other equation we have to write the equation line, if possible. So I'm going to work from right to left here. So 12 to 9 is minus 3. 9 minus 3 is 6. 6 minus 3 is 3. So if I continued on one more time, my next number here would be 0 because I'm subtracting 3 every time I go to the left. You minus 3 each time. Now, when I go to the right, when I go to the left, for my y values, I go negative 18 to negative 13, negative 13 to negative 8, negative 8 to negative 3. When I'm going to the left in this side of the table, you add 5. Negative 18 plus 5, 13. Negative 13 plus 5, negative 8. Negative 8 plus 5, negative 3. Negative 3 plus 5, positive 2. So my y-intercept, or I have that coordinate there, 0, 2. 2 is b for my slope-intercept form of a line. So we have y equals negative 5 over 3 times x plus 2.